We're going to keep going with the idea of derivatives as they apply to trig functions, and today we'll focus on the tangent, cotangent, secant, and cosecant functions and what their derivatives are. And then we'll build on tangent lines and normal lines. These are key building blocks because trig functions change, but change in a predictable manner. They make studying their derivatives real easy. So what I'm going to do is I'm going to give you the rules for you to memorize, and then we'll work on proving them. Okay, so yesterday we saw that the derivative of sine was cosine, and the derivative of cosine was negative sine. So in a similar way, both of the cosecant and cotangent both have negative derivatives as well. The derivative of tangent is the function secant squared of x. And the derivative of cotangent is negative cosecant squared of x. So there is some parallelism to those, and we'll prove that. I'll show you why that is true. The derivative of secant is a single secant times a single tangent, so secant tangent. And the derivative of cosecant is negative cosecant x cotangent x. And again, working on proving why that is true is going to be part of our lesson. We're going to start with the proof of the tangent of x. And we are going to not rely on Newton or Leibniz, but rely on the quotient rule to make this proof. So the first thing we're going to do as you prove the derivative of tangent is to replace tangent with its equivalent trig identity, which is the sine of x over the cosine of x. And by putting d dx out in front of that, you're making this announcement to the world, right? You're making this, okay, world, I am going to proceed with one of my derivative rules. And the derivative rule we're going to use this time is the quotient rule. So we start with cosine as the denominator function, and then we multiply by the derivative of the numerator, which is also cosine. Then we subtract, and we have the sine of x, and we multiply that by the derivative of the denominator, which is the negative sine of x. And we have that all over the cosine of x as a quantity squared. So my numerator becomes cosine squared x plus sine squared x over the denominator cosine x quantity squared. So we've got the identity 1, the Pythagorean identity, over the cosine of x quantity squared. So this is the reciprocal of the cosine of x quantity squared, which is the secant of x quantity squared, or we can write that as secant squared of x. So we have just proven the derivative of tangent using the quotient rule on its identity turns out to be secant squared. So let's look back at these other ones. So we just proved it using the quotient rule. The final three you will be proving in your homework. And you are also going to use the quotient rule to make that happen. And so you will do a substitution of its trig identity at the beginning, and then apply the quotient rule as a derivative, the derivative rules, to prove the following trig derivatives. But what we're going to do now is we're going to just move forward with the application, assuming that you believe me that those are true, and then you'll satisfy yourself with the proof in the homework. But right now we're going to find the second derivative of the following trig function. So the first derivative, using the rule from yesterday, we know that the derivative of sine is cosine. And we know the derivative now today of cosecant is negative cosecant x cotangent x. To find the second derivative, we'll continue with the rules. The derivative of cosine is negative sine x minus, and now here we're going to need the product rule to find the derivative of each of these pieces. So my product rule says start with cosecant of x and then multiply by the derivative of cotangent, which is negative cosecant squared of x. And then add to that cotangent of x times its derivative, which is negative cosecant x cotangent x. So now we've applied our product rule, and we just need to clean this up so it looks a little nicer. So we've got the negative sign of x on the outside. We're going to distribute this negative here. So that'll give me a positive cosecant cubed of x. And I'll also be distributing my negative to the last terms, and that will also give me a positive. And now I've got a squared cotangent and a squared cosecant. So that's the overall second derivative for that trig function. We can use our trig derivatives to keep going with the idea of finding a tangent line. And so we would want our point values and our slope values. So our point is pi fourths, and then the secant of pi fourths. So we want to think of that as pi fourths, and then the reciprocal of the cosine of pi fourths. So the cosine of pi fourths is rad 2 over 2. So the reciprocal of that would be 2 over rad 2. Don't worry about rationalizing, just leave it please in its unrationalized form. Now our slope would be the value of the derivative. The derivative of secant is secant tangent. And so this would be the secant of pi fourths times the tangent of pi fourths. We've already established that the secant of pi fourths is 2 over rad 2, and the tangent of pi fourths is 1. Therefore, my tangent line is y minus 2 over rad 2 equals the slope, also 2 over rad 2, times x minus pi fourths. So along the curve secant x at the particular point x equals pi fourths, this would be the equation of the tangent line. For our last example, we're just going to look at finding the normal line. And so again, you're going to be basing this on your point. So my point is pi, comma, the tangent of pi over pi. Okay, the tangent of pi, based on the period of the tangent function, is the same as the tangent of 0. And so this is 0 over pi. So my point is simply pi 0. My slope, I'm going to need the quotient rule to find the derivative of this function. So that would be x as a denominator times secant squared minus tangent of x, and the derivative of x is 1, all over x quantity squared. And now we want to plug pi in. So this would be pi times the secant squared of pi minus the tangent of pi times 1, all over pi squared. So the secant of pi is the reciprocal of the cosine of pi. The cosine of pi is -1. The reciprocal of that is also -1, and then I'll square that. The tangent of pi, we've already established, is 0. And we've got pi squared. So that gives me a numerator of pi and a denominator of pi squared. So my slope is 1 over pi. So my normal line would take the opposite reciprocal, and so I'd have y minus 0 equals a normal slope of negative pi times x minus pi. So the applications are a lot the same. Finding normal and tangent lines, finding horizontal tangent values. You're just using 4 new trig rules that we've learned today to finish up the rest of this chapter. So then we're going to spend some time applying these to other situations, more physical life situations in physics and physical science. But for now, you'll just be practicing all the trig derivatives. Okay, I look forward to seeing you on Thursday morning. I hope you have a good rest of your day.